This is section 3.5, and it's about transformations of graphs, how graphs change and what makes them shift in location and shape. Now, before we talk about that, we need to really make sure that you know the basic shapes. And some of you know some of these already. And we're only going to really focus on 4 at this point. So let's look at the very first one, which is y equals x squared. And the basic x squared is that shape that's like a U, and its vertex, the bottom, is at 0, 0. That one you may be familiar with. The second one is y equals the square root of x. It starts at 0, 0, and it goes to the right like this, and will go on forever. This one, I believe most people know, y equals the absolute value of x. It is a V-shaped graph, and its vertex is again at 0, 0. Y equals x cubed looks like a drain pipe. Goes up, goes through 0, 0, and goes this way. All right, so those are the basic. And if someone says y equals absolute value of x, you should kind of in your head have that picture of the V. All right, so that's the basic ones. But now let's talk about what happens to make this U shape. This red is your normal one. What makes it go up and down? Vertical shifts. Y equals f of x plus or minus k. All right, so if you'll notice, if you add a number to your little function, you shift up that many units. If you subtract a number, you go down that many units. So let's look. If you were putting it in your calculator and you could try it, you could put in your basic x squared, and then you could do x squared plus 3, or over here I've done another example, x squared plus 4 and x squared minus 5. And literally that vertex right here is what pops up if you're adding and down if you're subtracting. So that's what you need to remember. If you're adding something at the beginning or the end of the function, you're going to shift vertically. Now, how about horizontal shifts? What looks different about this? We're adding or subtracting something here, but it's inside parentheses or inside the radical or inside the absolute value. So if we have f of x minus h, that's going to go to the right h units. It's opposite of what you think. Typically we think subtraction, go left, but it's opposite. So you might just think about it this way. If it's inside, if we know it's horizontal, if it's plus, it goes to the left. If it's minus, it goes to the right. So in this example, here is your basic square root of x. Square root of x minus 2 takes that vertex and goes to the right 2 and then goes. Square root of x plus 4, and that's x plus 4 inside the radical, goes to the left and goes that way. It could be the same way if you had x squared. If you had x squared and you were doing that with it, and we did this, well, here's your basic x squared that actually hits there at 0. Plus 3 is going to go to the left 3. 1, 2, 3. And we would have, this one would be there. Minus 2 would go 1, 2. And we would be there. So the basic one shifting left or right. All right. Let's also talk about reflection. If you have y equals negative f of x, and we've seen that a little bit. We've talked about upside down parabolas. So x squared, here's your basic x squared. If you have negative x squared, it turns upside down, reflects over the x-axis. Does that make sense? Hopefully that's what you'll see. Now, with this one, you've got square root of x, and now we don't have a negative outside, but we've got the square root of negative x. it flips over the y-axis and goes that way. So those are two different reflections. Really, we're going to focus on this one in this section. And the last thing, if this coefficient in front of f of x, if it's greater than 1, it's going to make that skinnier. If it's less than 1, between 0 and 1, it's going to get wider. So this blue is your basic x squared. Red one is 3x squared, and 1/2 x squared gets wider. All right, so that's the basic transformations. Let's look at the problem set and see what we're going to be doing. All right, number 1. Let's get this. Number 1 says this is a translation of one of the basic functions. So they just give you all of them. But we see a parabola, so we know your basic one, would be right here. And so you've got this blue one, and it says find the equation. So you want to think, all right, where did I go? This vertex here went to the right 2 and up 3. So that's what I'm counting. Where did we go to get here? Now, I know this is going to be y equals, so I don't have to write that. It's going to be something with x squared. All right, up 3 means I'm adding 3 here. Right 2, remember right is negative, so we'll have -2, and that's what goes in that box. Number 2, find an equation that shifts by the desired amount. So here we've got x squared, but we're shifting right 4 units and down 3. So we've got x squared, but we're going right 4. That's opposite. When I'm going right, that's a negative. So -4, and then down 3 would be a -3 out here. So that looks like that's that one. Choose the correct graph that shows that. So the blue is where it's normal. Which one shows a red one that went to the right 4 and down 3? That would be this guy. Okay. Number 3, find an equation that shifts by the desired amount. So if this is your basic one, left 4 units, that means we're going to have an x plus 4. And upward 5 means we're going to be adding a 5 there. All right, so over here, let's think about this way. We've got x squared and a -3x and a -2. So instead of x squared, what are we going to have? We're going to have this x plus 4. And we've got -3 times x plus 4, because everywhere you have an x, it got shifted to the right 4. All right, and then we've got -2 plus a 5. All right, so that's what actually happened. Now let's kind of clean that up. The only thing that we can do, we can say that's a +3. So when you look at all these options, this one right here has what we've got, x plus 4 squared -3 times x plus 4 plus 3. All right, and then when you graph that, when you look at that, you could throw that in your calculator if you wanted to, and make sure it's going to be this one here. Okay. All right, because you're not starting out at your basic x squared. All right, and let's see. So if you wanted to graph this one and figure out where that was, it looks like the blue is the original. So that's the original. And because you can tell that's the same in everyone. So which one went left 4 and up 3? That's that one. So you could do that even if you didn't put it in the calculator. All right, number 4. Left 6. So that's going to be x plus 6. And down 3, that's going to be a minus 3. So we've got 1/2 times x plus 6 squared, I'm just plugging in, plus 2 times x plus 6, and then I've got -1 minus 3. All right, and so this -1 minus 3 gives us a -4. So now you can search through here and find the one that matches. Should be here. All right, so essentially you figure out what these are saying, plug that in for x, and combine the constants. Down here again, we've got the blue, that's the blue the original? It's gonna be, this is gonna be your answer. And I think this one is a little harder to see because the blue doesn't look the same on each of these. So what I would say would be to first put this one in your calculator and figure out which one shows that. And maybe put, put y1 equal to the 1/2 x squared plus 2x minus 1, and y2 equal to this one. I'll just put G so we'll know that. And then on your window, you make sure that you're at 20s on everything, and then you should get an exact picture of that. All right. Number 5, write a formula for a function whose graph is similar to f of x but satisfies the condition. So it's going to be similar to this but up 3 units. So that just means we're going to have a plus 3 here at the end. So we should have 8x squared plus 7x minus 6 and a plus 3 gives us a minus 3. So that works for that one. Number 6. All right, same thing. We've got y equals absolute value of x, but shift it left 5 and up 2. So remember that left 5 is going to be x plus 5, and then we're going to have a plus 2 out here, except this is going to be in absolute value for this one. And that is right here. All right, number 7. Use transformations to explain how the graph of f can be found by using the graph of y equals x squared. All right, so what it's saying is, how do we get to here from this? So if we've got an x minus 5, are we going left or right? We're going to go right. So let's look here. This one's a right, and okay, that's the only one that's right. And then we're going to put in the 5 in that box and vertically shifting the graph up 2 units. So 2's going there, and we choose that one, okay, because x minus 5 told us we were going to go to the right 5. All right, number 8, same thing. We've got negative square root of x minus 6. So our x minus 6 tells us what? That we're going to go to the right 6. The negative out front says that we're going to be reflected over the x-axis. Remember, we're going to go upside down. So let's see. These two say right 6 units. This one says reflected about the y. This one says reflected about the x. All right. Now, on number 9, you're going to use this graphing tool, and you want to click the parabola tool first. So you're going to click this guy. All right, we're going to click that one, and let's see, I think You're going to click that, and it will give you a parabola tool, but I think over here maybe I have something that will show you. Yeah, let's look. So we pick that one, and it's going to give us this, but it will give you the translation. And so what are we doing? We are doing a vertical shift. So here, go down to the vertical shift and move it over to -10. And so that will move the graph down. So you have to do two things. Be sure you pick the parabola tool and then do the vertical shift slider bar to go in the correct direction. If that had been a plus, we would have been moving up. If it was a horizontal, you could go left or right. So I think that should do that for that problem. All right, let's go down to 10. Sketch the graph of this one, and on this you can just figure it out and choose the right one. You just have one of those where you're actually graphing. So absolute value of x, we know it's a basic absolute value, but it's popped up 2. And so when you're looking at all these, this is the one that matches. All right, on this one we've got square root of x minus 2. So remember that the basic square root of x does that. X minus 2 says we're going to go right 2 and up 3. So we want to find the one that went to the right 2 and up 3. And I believe it's right here. And that should get us some practice on transformations in 3-5.